Alright, so final array state after k multiplication operations. Part 1 and 2 is what we're going to see in this video. The question says that we are given a nums array and an integer k and a multiplier, and we are asked to perform k operations on nums. And for each operation, we'll have to find the minimum value in x, in nums, and replace that value with x into multiplier, and then perform this two operation again and again for k times. If we try to do it mentally, know uh, we see that a data structure that pops up in our mind, that is priority queue, that we can use. I think we can also do it brute force using sorting, or even traversing to find the minimum element. But priority queue is, I think, the more optimized way of doing this. So priority queue is what we are going to see. Priority queue. This will be a min heap because you want the minimum every time. So, but if we take the minimum and we push, we push it eventually, to find the minimum inside priority queue, but we'll lose its index. But by the end, we need the index, right? So we should push a pair. Uh, Vector of n, the value and index. First will be in value, and then the second position will be index. Alright, this will be vector of n. This will be min heap. So let me call it pq, and I'll just reverse or enumerate. That's better. Let me get the size as well outside. Alright, and at this point I'll push it inside priority queue. Push along with the nums, the value and index. By the end, I will traverse k times, get the minimum, which is the top, and basically push the top of 0 multiplied by multiplier, comma, the index will be the index. That's the second element, the second position. My bad. So 1. Alright. Now I will pop. So if I multiply, uh, that element will still be, the minimum will be still at the top, right? So if I pop, that does not mean I'm popping this. It's not a stack, which means I am popping this. So if in case the multiplier is 1, right, then I am just pushing the value again and then popping it. So minimum is the same as what I would have pushed. So it's not going to matter. And I'll do k minus minus. This will continue, and by the end I will q.empty, get the things out and paste it inside nums. That will be nothing but pq.top, index will be the second position, and the first position will be the value, which I'll assign it here, and I'll pop. By the end I should have the required nums. Let's see if this works. Priority queue, so time complexity will be O of n log n. Sorry, there should be a bracket here. This works. I think it shouldn't overflow. If it does, then I'll probably have to. Okay, it doesn't. Alright, the second problem, which is exactly the first one, but just that we have greater constraints, so we need to take care of the overflowing part using modulo, and the constraint is this: the time complexity was O of n log n. If we look at this, then actually it's not O of n log n, it will be O of n log n here, since we are pushing inside priority queue, but it will be k into log n. So essentially it's n log n plus k log n, which if we do it here, then we see that k is the bottleneck here. We can afford to have nums inside our time complexity, but k is what we need to optimize. This is the same problem. So if we try to dry run this using the same way that it is said, just it's a simulation, I'll have a min heap like I did previously, and let's do the same thing again and again to see a pattern. All right. So I will have to actually I'll have inside min heap it'll be sorted. So 1, 2, 3, 4, 5, 6. Index will be actually 4 is not there. My bad. Index will be 0, 1, 2, 3, 4. All right. Now if I multiply, or actually let me do it this way: 1 comma 1, so 1 2 3 4, 1 comma 1, 2 comma 0, 3 comma 2, 5 comma 3, 4 comma 6 comma 4. Alright, so this is my main heap right now. I'll do the same thing that is said. I will take the minimum, I'll multiply 4 to it, and I uh, move multiply 2 to it. So 1 into 2 will be 2. So since multiplier is 2, so this will stay here, nothing will change, just that k will decrement by 1. So it will be 4 instead of 5. Now I'll do the same thing, multiplied by 2 will be 4. I will have to pick this up. Now order will be like this. This will decrement by 1. I'll do the same thing here. I'll pick this up and I'll make it 4 first. I'll multiply. I'll pick this up. I'll move ahead and I'll push it here. This is how min heap works. Now comes the interesting part. So if I take this and do the same thing, I will see that this will be going to the back, and everything that comes next is will go back. Will go to the back of the menu because it will be the maximum, right? How did I found out this point that this is going to the back? That's because I see that at the top or the maximum will be 6, and I multiply 2 to 3. Oh, actually it won't go to the back, my bad. This will go here. Let me do once more. So 6, I pick this up and move it here. This will be here. Finally, k will be 2. Now, if I multiply 4 by 2, that'll be 8. So it'll go to the back. I'll multiply 4 to 8, go to the back. 5 to 2, sorry, not 8, 2. This will also go to the back. 6, 12, back. 6, 12, back. And this will continue forever until we have exhausted k. Right? Make sense? How did I found out that at this point this will go to the back? I knew that 6 is the maximum. So I should have a max element, that's 6, right? So right at the start, when I initialize, I'll have a maximum element, I'll have a min heap, I'll have a k. So at this point, how many times? So the question is not over. How many times at this point I will go to the back, right? That is k number of times, the remaining k number of times. So essentially, we have not optimized anything, right? But we see a pattern that this will continue until and unless k has been exhausted. So there might be a situation where, just for an example, right now k is 50. Okay, since we have a longer k, greater k values, so we can have k is equal to 50. So if k is 50, then we see that I will continue to do the operation that I just said. Multiply 4, this becomes 8, this will go back, this will go back, this will continue forever. What we can optimize there is, we can see that we have to divide eventually evenly to all the elements of the main heap, right? How many elements are there in the main heap? There will always be nums dot size element. So what if I can just, this is n is num size, that's 5 here. So what if this was 52, or actually 50 is fine for now. I'll get the even division, or the evenly I will distribute 50. How many times? Let me frame it correctly. So there are 5 elements. I will have to distribute 50 things among the 5 elements. That's the question. So I will have, for example, I'll name it uh, L or P. Alright, P is K divided by N. That's nothing but 50 by 5. That's nothing but 10. So this means that 10 times I will multiply each element. So why not just traverse this and multiply each element 10 times, and that's nothing but multiply each element by multiplier 10 times, which is nothing but value, which is every value that I iterate, into power of multiplier, comma p. So this is what it essentially means. I'm doing this operation for every element inside nums. But what if there was some remaining elements which makes it not divisible by n? So there will be some remaining elements, right? So 52. So I'll divide 50 evenly, but there will be 2 elements which will go to just these 2, the minimum 2. In that case, I will just have a remaining k, which is nothing but k mod n. So that will give me the remainder, which is nothing but 50 mod 2, or sorry, 50 mod 5, which is, sorry, 52 mod 5. Now it's 52. I'll make this 52, which is 50, sorry, 2, which is 2. So I'll, for 2 remaining elements, I will iterate this. So since I will be iterating here and then the remaining here, so I'll make this a vector in this order itself. Why in this order? Because the remaining elements, the evenly elements is fine. I can just iterate it in any order. But the remaining elements should be in order and that is this order, main heap order. All right, so that's how we are going to solve this. And we did nothing, just that we, uh, you know, we increased k because we see we did a dry run on the first example, and we just increased k to see what will happen because there was in the question itself the constraint is different, and we found out that that's what we need to do. This is still tricky, but let's see how we can solve it. Priority queue. I will have again vector of int. So vector of int. Let me copy this. Actually, this entire thing. Let me copy. Let's see anything needed. This is needed, but in a different way. So I will do this. I mean the one that I was doing the simulation, but for a point. And till what point? Till the maximum element, that will compare. So I have a maximum element, or let me call it maxi, which is initially int min. I'll traverse. I'll get the maximum. Max e is equal to max of max e, comma nums of I. And finally, I will iterate as long as k is greater than 0 and max element or the max e is smaller than or equal to uh, pq dot top of 0 multiplied by, this is the value at the top, this is the minimum value multiplied by multiplier. If this goes above max element, then there is a cycle that is going to start from here. So it's good time to break. So I'll break. Uh, at this point, I will find P, that is, so P is K by N, K, whatever remaining K is, and N is the size, int remaining K. So this remaining K will be after evenly distributing the P. I will have some remaining K. I may have some remaining K that will be K mod N. So I will write it here K mod N. Finally, I will get it. Since I will be iterating this, so in this order I will get vec, right? Uh, yeah, yeah. So vector of int. Let me call this vec. I will just iterate through the priority queue. Pq dot for vec dot pushback along with its index. So I'll have, because at the end I will need the index to create my final answer. So let me call this vector of vector pushback pq dot top. Finally, I will traverse to 0 I less than. So I'm traversing for even distribution right now. Let me write this for even distribution, which can be 0. There can be a scenario where k is 4 and n is 5. In that case, this will give me 0 and remaining k will give me 1. Right? 4 mod 5 is 1. So, or actually 4. Sorry, 4 mod 5 is 4. So it will give me 4. So this will run for uh, p times, sorry, n times. This will be even distribution for entire array row. Alright, so I should have a p is equal to greater than 0, because if p is equal to 0, I will iterate, you know, for no reason. I'll do nothing because p is 0. That's why. So I should not even iterate for even distribution if p is 0. At this point, I will change the first value, which is 0, by what? Index will be remaining index, whatever it is, into multiplier. But how many times multiplier? Multiplier, comma, uh, multiplier, comma, what is it? Multiplier, comma, p. So p times. So p times every element is multiplied by multiplier, so it's nothing but multiplier power k. So multiplier power p. So that's it. This will change the values for int I is equal to 0, I less than remaining k. Right, so I plus plus, this will be the remaining k elements for remaining k. Alright, so this will be just a multiplier with a single power. Power p is 1 here, so there is no power. At this point, I will create a vector of answer. I'll traverse this one by one, and I'll get the this first position, that is the index. I'll push it. I'll create of this size. I will have nums or vec of I first will be index is equal to vec of I0. This is the value, and return answer. This is what we have simulated, but there is some problems because this is a modulo, so it will have big multiplications. As we have seen that k can be very large, and uh, multiplier can also be very large, so this can go beyond uh, integer bounds, and that's why we have to keep or keep modding things. This will overflow, and this can overflow. Let me just run it and see if it's working. Otherwise, is there any other mistakes? Line 15. So here itself, I think this is overflowing. Let me remove this test case for now and see this. If this simple one passes, it doesn't. Let's see if k is greater than 0. This is a min heap. Max element is here. Max element is less than equal to, my bad, greater than equal to. So as long as max element is already greater, then I should do that. Okay, this works, but now let's fix the modulo part. The problem is majorly here. Here, power multiplier to the power k can go beyond. I cannot do just mod here because in between itself, for some power, it will go out of bounds. So in that, I have to do it one by one exponentially. So for that, I can call a function. Uh, Let me call it outside. This is nothing but, let me call it mod xp, which will keep on modding for every power. So I'll have a base, I will have a exponent or power, and let me call it this. I will have a mod. So this is mod 1 9 plus 7. So I'll do it recursively. You can do it other ways as well. Uh, Base is, if it's equal to 1, then I can just return 1. So let me just make this here itself. Exponent is equal to 0, then there is no point on multiplying. The answer will be 1 always. And I will call this, let me call it half. I'll call this for half, and in that half I will mod it. So essentially I am getting the base, I'm dividing the exponent by 2, and I'm modding it always. Alright, so I'll call it for half, and I will just, since the other half will be same, it will be base of exponential of by 2, so I'll just multiply it half by half, and as I multiply I also do, I keep on modding. But what if exponent is 1, it's not divisible by 2? In that case I just need to multiply base once only, because exponent is 1, so base to the power, anything to the power 1 is the base itself. So in that case if exponent mod 2 is not equal to 0, in that case please multiply half by uh, base itself, and also do mod and return half. Alright, so this is what it is, and let's see if this works. There might be other cases. So here I return, so I'll keep on modding here as well, and wherever I'm multiplying I keep on modding. And also one edge case is if multiplier is equal to 1, in that case this entire calculation will be useless, because multiplier is equal to 1. I can just straight away return nums or whatever it is. And now let's see if this works. Alright, so there is, oh my bad, I just created the function but I didn't use it itself. So mod xp, multiplier is base, p is the power, and mod is what I'm passing. Let's see if this works. Okay, line 51. So I'm modding it. Let me just create long. So this time complexity will be O of n log n. Uh, this one will be O of since I'm doing it, either I'm doing it for the entire array k, so this is never true, or I'm doing it for few, right? So it will be in worst case k of log n. Uh, this will be O of n. This will be O of n. This will be more than O of n, but it won't be too much because we are decreasing exponentially. So uh, this plus this is going to be the overall time complexity which is dominating. This will also be O of n, and overall time complexity will be uh, O n log n plus k of actually k will never be this will never go on for k times. If k is large, then this will eventually find a cycle, and this will not happen, and this will start happening, and this will optimize things. So eventually it'll be this, I believe. I'm not really sure, but this is the question. It's a tricky one. Thanks, guys.